So welcome friend once again. So in this sessions of video we are going to learn about how the Quanta motherboard power sequence work. In previous Piston video we understand how the things are work. See, every company, whichever it is, whether it is Compil, Quanta, Wistron, Inventec, Asus, they work only according to the Intel power structure, like it's called the ACPI power structures. It's called that power state. It's called the S5 state, then S4 state, then S3 states, and S0 states. These are the power states, and they have to design their motherboard according to the ACPI power states only. But sometimes their signals are different from here and there. So when we are going to repair these motherboards, so the signals are little different, their names are different, and their sequence are different. So in Wistron motherboard we understand the different sequence, and now in this video we are going to learn about the Quanta motherboard. The Quanta motherboard number basically start from DA. Okay, the DA number start for the Quanta motherboards. So normally used in HP or Dell laptops, any other, all lab manufacturers use the Quanta motherboards. Okay, so we are going to learn about the sequence. So here is my processor. So this sequence we are going to learn about the latest motherboard, the latest new generation motherboard. So here is a CPU, then here is a SIO, here is a BIOS, and these are the different buck converter, like these buck converter for the RAM DDR3L, and if it is a DDR4 then 1.2 voltage, then 1.05 voltage, then this graphics core, then 1.5 volt, and then the CPU core. This is a 3.35. Okay, so different buck converters are here, and this is the CPU, and this is a VIN section. VIN section means voltage input section. Whether there are two inputs, you receive the power from two inputs. One is called the adapter and one is called the battery. These are the two inputs, and when we connect two input, the adapter voltage passes. So here I given the number. So this number you have to follow this number. So step number one is voltage input. So suppose here is a adapter voltage is a 19. So my adapter voltage is a 19. Then 19 volt come here. Okay, so here will be 19 volt. Here will be 19 volt. Here will be 19 volt, and this 19 volt goes here. So these are the different buck converters. This is for the DDR. Okay, this is for the 1.05, that is a PCH CPU, and then this is a 1.5 voltage. So these are the different buck converters. Okay, these are the buck converter work only after power button press, but the step number one is work. Then in step number two, VRG3 voltage will be generated. That's called LDO. It's called low drop output, or VRG3, and this 3 volt is going to the SIO. Now SIO got the power, SIO is ready to work. Then SIO get 2-3 signal, like it's called a lead switch, that is a 3 volt. Then AC, that is a 3 volt, and if the temperature, then the 3 volt. Okay, so these are the input criteria to the SIO. So once SIO got all this input signal, then he's ready to work. So his SIO's wait for the power button. So here is a power button. It's called power button, or it's called NBSW on, or power switch. So on the power button there will be 3 volt, and once that power button is pressed, that 3 volt become into 0 volt, and we release that button, is back to 3. So 303 bounce is created on the step number 3. So once this step number 3, the power, when we press the power button, then the SIO release this signal. At step number 4, SIO release this signal. It's called SLP underscore S5. Okay, SIO release this signal, SLP underscore S5, and this signal is given to always power. Always power means 3.3 volt and 5 volt section. So 3.3 and 5 volt buck converter turn on at this moment, and then 3.3 and 5 voltage will be generated at step number 5. So if this signal is not coming out from the SIO, then the SIO is probably bad. SIO is faulty, or the EC bias is faulty. So you have to check that signal. Okay, so this signal should become after pressing the power button. Then this both voltage will be generated, 3.3 and then the 5. This 3.3 is going to the CPU. It's called VCC DSW. VCC DSW, deep sleep power okay signal. This is going to the CPU. CPU get this RTC VCC, then clock, RTC clock, then DPWR okay. So this signal get the CPU. CPU is ready to work at step number 6, and then the step number 7, SIO send out this RSM RST signal at step number 7. Then at step number 8, SIO generate PM power button. SIO generate the PM power button. It's called the post power button. It's called, sometimes this signal is named DNBSW on. Just remember this name, DNBSW on. This is the output signal. And at step number 8, 303 pulse will be generated by the SIO, and this signal is going to the CPU. Okay, and then at step number 9, now the responsibility of the CPU to generate two output signal, and this signal is called SLP underscore S4 and SLP underscore S3. So once CPU receive this signal power button saying the power button is pressed, then the CPU generate two signals called SLP underscore S3 and SLP underscore S3. Both signals should be 33 volts. You have to check both the signals should be 33 volts. Now, if this 33 volt is not coming, then your CPU is not responding. Okay, now why the CPU is not responding? In that case, you have to check 3.3 volt VCC DSW. Then you have to check DPWR okay signal, that is a 3 volt. You have to check RTC VCC, RTC reset, and this crystal 32.7 kilowatt crystal. If all the signals are properly and still SLP S3 and SLP S4 is not generating by the CPU, then the CPU is bad. So you have to replace CPU. Okay, step number 9. Then after once SIO received this signal SLP S3 and SLP S4, then SIO generate the signal number, step number 10. This is called sys on. Sys on. This sys on turn on the DDR supply, whether it is DDR3L, then 1.35 voltage. If it's the DDR4, then 1.2, 0.6 and 2.5. These are the three voltages generated on this sys on signal for the DDR4. Then the next signal will be 13 number main on signal. The main on signal will turn on 1.05 voltage, and that after that there is a 1.05 voltage generated, and that this voltage is also going to the CPU. Okay, then after see, here is a one signal is called a HWPG. HWPG is a hardware PG, that means the power good signal. Now here is a something like a AND gate. Okay, so what happen is here, so once this all power supplies are turned on one after another, then they generate their power good signal, and they all power good signal come here. So always power good signal come here, that is a 3 volt. Sustained power good signal generate, that is a 3 volt. Main power generate, that is a 3 volt. System on, that is a 3 volt. So all power good generate the 3 volt, 3 volt, 3 volt, and this all 3 volt is something like a AND gate. And if one of the signal is missing, if one of the supplies is, suppose this 1.2 voltage is not generating, so that 1.2 won't generate a power good signal, then the power good signal will be 0 volt. So it will drag all the 3 volt, and this power good signal will be 0 volt. Okay, so if one of the signal is missing, then here will be 0 volt. If all signals are there, that means all voltage are present, then here is a HWPG will be 3 volt. And here if the HWPG is a 3 volt, then SIO generate this signal, that step number 16, that is called a VR on. SIO will generate the VR on. The VR on signal turn on the CPU core voltage, and the CPU core voltage going to the CPU. Okay, the CPU core voltage will be generated, and then the IMPP power grid will be generated, CPU power grid will be generated at step number 9. So here the all supply will be generated one after one after one after another, and then the CPU receive this signal is called the system power. Okay, if the graphics core voltage is there, then the graphics core voltage will be generated. The graphics RAM supply is there, then the RAM DDR RAM for the graphic that also will be generated, and then finally system power okay signal will be generated. The system power okay, the final signal in the power sequence saying that the all power planes are okay, all supplies are okay, and this signal is generated normally by the SIO. Okay, system power okay, just remember this name, system power okay or EC power okay. Okay, this signal is going to the CPU, it's saying to CPU that all power planes are okay, and after that this signal CPU generate PLT reset, platform reset, this important signal, platform reset or the PLT reset, reset the entire motherboard, and then the BIOS started functioning. So in this way the Quanta motherboard power sequence work.